heights and distances. In this chapter we are going to learn how to find the heights of a tower or a long distance, a distance that's so long that you cannot measure it like with a scale. So before we study this chapter, let us learn certain terms that we'll come across. One is called the angle of elevation and angle of depression. To understand what is angle of elevation, look at the first picture. Here you have a person. AE is a person, and this person is looking at this tall tower. I think it's a Qutub Minar here. So let us learn what you mean by angle of elevation. Now this person, his line of sight, he looks at the top of the tower. So this is his line of sight. And here is the horizontal. His point of observation is his eye. So it comes right from here. The angle between the line of sight and the horizontal, this angle is called the angle of elevation. Here they've given you angle of elevation. So what is angle of elevation? Angle of elevation, to find the angle of elevation, first you must know the line of sight, and then you must know the horizontal. It is always the angle with the horizontal is called the angle of elevation. So this whole picture can be now drawn in the form of a triangle, which will help us then to find the height. So here is the horizontal. This is the line of sight. And here is the tower, the height of which we need to find. This is the angle of elevation. So for this slide is enough for you to know how to draw the angle of elevation. This is the point of observation. A is the point of observation. So the angle of elevation is the angle between the horizontal and the line of sight at the point of observation. So it's the angle between two things, angle between horizontal and the line of sight. You need to draw the line of sight and the horizontal, and the angle between them is called the angle of elevation. Now this is to be drawn at a point of observance, point of observation. This is another picture. Look at this child is looking at the kite. The kite is up here. Here is the kite. So that's the object. Now we want to draw its angle of elevation. First we need to draw its horizontal. So this is the point of observation. The eye is the point of observation. So we draw the horizontal. And then we draw the line of sight. This angle between the line of sight and the horizontal, this angle is called the angle of elevation. So this angle here is the angle of elevation. Next we learn angle of depression. Now the angle of depression comes into the picture when we are looking down. So the point of observation is up. Like in this case you can see this girl, she's standing up here and she's looking at an object down. So again we need to draw two things. First we need to draw the horizontal, which is here now. This is a horizontal at the point of observation. And then we need to draw the line of sight. The child is observing this object. So the line, this is the line of sight. Here is the line of sight. And the angle between them, this is the angle between them, will be the angle of depression. So the angle of depression is the angle between the horizontal and the line of sight. But angle of depression is usually used when we are looking down. So angle of depression is between the horizontal. We have to draw the horizontal and line of sight. The angle between these two will be the angle of depression. We need to revise a few more things. Suppose we take this as the angle. I'll mark this as ABC, and I'm taking angle C for angle C. we have the perpendicular and the base. For angle C, the opposite, that is AB will be the perpendicular, BC will be the base, and of course if this is 90, the hypotenuse will be AC. So you have done this in Trigo. So the perpendicular is AB, the base is BC, and the hypotenuse is AC. But now if we take for angle A, for angle A, the perpendicular will be BC, AB will be the base, and this will be the hypotenuse. So you need to remember this. So for angle, if we need angle A, here the perpendicular in this case will be BC, the base will be AB, and hypotenuse will be AC. We also have to remember our trigonometric ratios. For example, cos theta. Cos theta is base over hypotenuse. Sin theta is perpendicular over hypotenuse. And tan theta is perpendicular over base. Some ratios too, like sine of 30. Sine of 30 we must know is 1 by 2, and remember the sine of 30 is the same as cos of 60, which is also 1 by 2. Then we need to remember sine of cos of 30. Cos of 30 is root 3 by 2, which is equal to sine of 60 is root 3 by 2. Then we need 10. Tan of 30 is 1 by root 3, and tan of 60 is root 3 by 1. We need this information while solving our sums. A circus artist is climbing a 20-meter rope. So the rope is 20 meter, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground is 30 degrees. So here's the diagram. We have a pole and we have a rope here. So this is the pole. AB represents the pole, and from the pole there is a rope that is tied. So AC is the rope, and they said the angle between the rope with the ground. So here is the rope and here is the ground, and this angle between the rope and the ground is 30 degrees. We need to find the height of the pole. So in this triangle ABC, we need to write AB represents the pole, which is equal to 20 meter. No, pole is not 20. Or we say we don't know the pole. We need to find. We call it as H meter. So we put this as H. Then AC represents the rope, and then this rope is 20 meter, and the angle between the ground, that is BC, and the rope AC, the angle ACB is equal to 30 degrees. The next question comes, which ratio are we going to use to find sin theta? Are we going to use cos theta, or are we going to use tan theta? To answer this question, first mark the angle. You know the angle is given as 30. What else is given to you? AC is given to you as 20. What do you need to find out? You need to find out AB. This H is our question. Now when it comes to 30, you see the 20, that AC is the hypotenuse, and AB, which we need to find out, is a perpendicular. Now which ratio deals with perpendicular and hypotenuse? And you know the ratio is sine. So we are going to start using sine theta. So we say sine theta equal to perpendicular over hypotenuse. And here we are using The theta is C, so theta is here 30. The perpendicular for C we already have seen is AB, and the hypotenuse for C we have already seen is AC. Sin theta we know is 1 by 2. So 1 by 2 equal to H, which we have to find out, and AC is 20. Cross multiply, we get H equal to 20 over 2, which is equal to 10 meters. So for the answer, the pole, which in this case is represented by AB, equal to 10 meter. So you know why you choose sin 30. You chose sin 30 because what was given to you? What was given to you was this hypotenuse, and we had to find out the perpendicular. So you need to use sin theta. Let me go over the sum again, just summarize it. So this angle was given to you first as 30. Here we had 20, which was given to you, and this was our question. We will put this question. This is H. And now you want to know which ratio to use. Here is hypotenuse. This is perpendicular. Hypotenuse and perpendicular give you sine. So you started with sine 30. Sine 30 perpendicular over hypotenuse. Or you need to put the ratios 1 by 2. That is H you don't know, and 20. So 20 over 2 equal to H, and H equal to 10 meter. You need to draw the diagram. Of course, to draw the diagram, the pole was given. They said this was the pole, and from the pole you had a rope that was tied, and of course the base was the ground. A tree breaks due to a storm, and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. So here's the tree. Now because of the storm, the tree breaks, say maybe at this place, it breaks down here. So now the tree will be, this will be the part that's not broken, and this is the unbroken part. So it will break up like this. So first the tree was BD, was here. Now this is B, and the top of the tree has reached here. So this is our D. Now next they said the broken part touches the ground at an angle 30 degrees. So which angle is 30? The ground, between the ground, this is the ground, and here is a broken part, and this angle is 30. So let's mark this angle here as 30. Then they gave something as 8 meters. What is 8 meters? The point where the top touches the ground is 8 meters. From the foot of the, so here is the foot of the tree, and this is where it touches the ground, and this is 8 meters. I'm going to put it in another color. So here is the distance between the foot of the tree, here is the foot of the tree, and this is where it touches the ground. So that is 8 meters. Let me repeat that. The distance between the foot of the tree, this is foot of the tree, and where the top touches the ground is 8 meters. So here we will write this angle, it say cuts at A, so this would be A. So we'll draw the figure again. This was B, here was A, and this was D. And we took this angle as 30, which was given to us. This was given as 8 meter. Now we need to find the height of the tree. Now what will be the height of the tree? Now if you remember, this is the height of the tree. BD, this entire BD is the height of the tree. Now in the diagram, where is the height of the tree? It is AB plus AD. So we want to find the height of the tree. We need to add up BA plus AD. So we now get on to the sum. The angle given to us is 30. Let's go ahead and find out AB. So I'm going to put AB as, say, X. Now what do we use? Sine, cos or tan. So for that we'll write the angle equal to D, angle D, which is 30 degrees. What is given to us here is BD, and you know BD for 30, what is BD? BD is the base, and we need to find AB. Here AB is not the hypotenuse, I made a mistake there. AB is a perpendicular. So when here we have the base and perpendicular, we are not using cos, that is a mistake. I've corrected it later, so you may ignore this part of the sum. Yeah, so have you seen there? Now that is the perpendicular, right? So this was wrong. This has to be perpendicular. So we cannot use cos. Let me do this again. This is all not proper. So we have base over perpendicular. So we are using tan 30. Tan 30 is perpendicular over base. And the perpendicular is AB, and the base we saw is BD. Tan 30 is 1 over root 3 perpendicular AB that we don't know, and the base is 8. So 8 over root 3 equal to AB. So we found AB as 8 over root 3. Now we need to find AD. Now in the next part we already found AB, now we need to find AD. So our AD we will put as X or Y now here, this AD. What is given to us is 8. Now 8 we know is for 30, 8 is base and AD is hypotenuse. Base and hypotenuse we have to use cos. So we have for angle D, the base, which is BD, is equal to 8 meters, and the hypotenuse, which is AD, equal to Y. Now base and hypotenuse, so the ratio we need to use is cos. Cos theta is base over hypotenuse. In this case our theta is 30, so cos 30 base is 8 over hypotenuse we don't know, that is AD, and cos 30 is root 3 by 2, which is 8 over AD. Now AD will be 8 into 2 over root 3. So AD will be 16 over root 3. If you remember, what was the height of the tree? Height of tree was made up of AB plus AD. Let me go over that again. The total height of the tree was AB plus AD. We already earlier found our AB as 8 over root 3, and now this is 16 over root 3. So when you add up here you get 24 over root 3. Now we'll rationalize it into root 3 into root 3, and the answer comes 8 root 3. So the height of the tree is 8 root 3. A contractor plans to install 2 slides for children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meters and is inclined at an angle of 30 degrees. Let's draw this figure. So here we have a slide. There is a slide here like this, and they said that the top height of the slide is 1.5. So this is the top height of the slide. So that is 1.5. And the angle, it is inclined at an angle of 30 degrees. Means if this is the ground if here is the ground, the angle of inclination is 30. So this is the angle that is 30. We need to find the length of the slide. So we'll mark this A, B and C. So in triangle A, B and C, AC, which is equal to X and we don't know, is the slide, represents the slide. AB, which is 1.5 meter, represents the height of the slide above the ground. And BC represents the ground. Now remember, we need to find the length of the slide. So our X is here. This is our X. Now which ratio are we going to use? To find out which ratio we are going to use, first we have to do angle. Our angle is C. Now in this angle, what is given to us? 1.5. And AB, if you see for C, what is AB? AB is perpendicular. So AB is given to us, which is 1.5, and you know AB is a perpendicular. We need to find AC. AC is X and AC is a hypotenuse. This is hypotenuse, right? So perpendicular hypotenuse, which ratio do we use? Perpendicular hypotenuse gives sine. So we have sine, we are going to use the ratio sine theta is perpendicular over hypotenuse. In this case, the theta is 30, so sine 30, perpendicular 1.5, hypotenuse AC, we don't know. Sine 30, 1 by 2, 1.5 over AC. So our AC is 1.5 into 2 and AC equal to 3. That was a slide for the small children, and there's yet another slide for the bigger students. The eldest students, children have a steep slide at a height of 3 meters, inclined as 60 degrees. So for the oldest student is a little longer slide, and it is at a height of 3 meters, they said, which means this height now here, this is the height, is of 3 meters. And the angle with the ground, say here is the ground, and the angle of the ground in this case is 60. It's a steeper slide, 60. So we'll mark P, Q, R, and in triangle PQR, PR represents the slide, PQ represents the height of the slide, and RQ represents the ground. Next, let's see which ratio we need to use. So the angle given to us here is 60, angle 60, and we know this PQ for 60, PQ is perpendicular. We need to find the length of the slide, this X, and here this is the hypotenuse, so we write that too. So PQ is given to us, PQ is 3 meters, which in this case is perpendicular. We need to find PR, which is X, in this case is hypotenuse. So we have perpendicular and hypotenuse. Perpendicular hypotenuse means we need sine. Sine of theta is perpendicular over hypotenuse. In this case it is 60. Sine of 60 is perpendicular over hypotenuse. Sine of 60, root 3 by 2. 3, hypotenuse is X, is what we need to find. So X equal to 6 over root 3. So X equal to 6 over root 3. Now you rationalize. So into root 3 into root 3. And this will be 2 root 3. So for the answer, we have length of slide (2 root 3 meter). the angle of elevation of a top of a tower from the point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. Find the height of the tower. You know, in these sums, the first step is to draw the diagram. So if you see the diagram here, we have two things. We have tower and we have the ground, and from the ground we are looking at the top of the tower. So we'll draw that first. So say this is our tower. AB is the tower, and here this is the ground. And from a point on the ground, there's one point here on the ground, we'll mark this point, say C. We're looking at the top of the tower. So we have drawing the line of sight. Here we're looking up here at the tower. So this is your line of sight. So we have drawn the diagram. Now they said the angle is 30. So which angle is 30? The angle of elevation. Now remember, angle of elevation is angle between the horizontal. The horizontal is this blue line here. This is the horizontal. Angle between the horizontal and the line of sight. This angle will give us angle of elevation. So here is our angle of elevation, and in this case it said the angle of elevation is 30. So we have marked 30. Now they've given us another figure, that is 30 meters. Now what is 30 meters? Which is 30 meters away from the foot of the tower. So where is the foot of the tower? Here is the foot of the tower. B is the foot of the tower, and C is the point. And the distance between that is 30 meters. So here we have 30 meters. So in the triangle ABC, AB is it represents tower, and the BC is the distance from the point of observation, and of course AC is your line of sight. So here's the figure again. This angle is given as 30, and we need to find the height of the tower. So let's put X where we need to find. So here is X. So back again, we need to know the angle. Angle C is 30. What we are given is AB. We're given AB here, or we need to find AB here. So we write AB. AB is X. We need to find it, which in this case is perpendicular. You'll agree AB is perpendicular. And our 30 BC, this BC is the base. Given to us is BC, which is 30, and this is the base. Now perpendicular and base, so the ratio we are going to use is cos. No, 10. Perpendicular and base is 10. 1030. 1030 is perpendicular over base, and in this case AB over BC. So we'll calculate. 1030 will be 1030 is 1 by root 3. 1 by root 3. AB is X, BC is 30. So 30 over root 3 equal to X. So here, so you need to rationalize. Into root 3 is X. 30 root 3 over 3. So 10 root 3 equal to X. And X is the height of the tower. So height of tower equal to 10 root 3 meter. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. I won't read further. Let me just draw this diagram. So we have the ground. Here is the ground, and we have a kite flying up here. Okay, 60 meters above the ground, which means This is 60 meters above the ground. Now let's read further. The inclination of the string with the ground is 60. So we need to draw the string. So say now the person is flying the kite. He's at this place here, and this is the string. This would be the string, right? All right, here this is the string. Here is the kite. And the angle of inclination to the ground, which means this angle here, this angle, inclination angle, is 60 degrees. So we've got our triangle. Find the length of the string. Length of the string, where is the length of the string? Here. So this is our x. We need to find this x. So this is our diagram. We'll mark the points. So we'll mark this as A, the kite, B is on the ground, and C is on the ground. So in this triangle ABC, you mark AC represents string, and in this case we will take as x meter. Then AB represents, look up and see what AE represents. Represents the height of the kite, how high it is from the ground. Okay, now which is given here as 60 meter. So here's the diagram. I've drawn it. Now this is 60 degrees. Let me mark the perpendicular, base and hypotenuse right in the beginning. For 60, perpendicular, hypotenuse, base. Now let's get on to the sum. So angle 60, angle C equal to 60. What is given to us? 60 is given, so AB is given to us. AB is given as 60, which we know is perpendicular. We need to find AC. We could put it as x, which is hypotenuse. So there is perpendicular and hypotenuse, so we need to use sine. Sine 60 is perpendicular over hypotenuse. In this case, perpendicular is AB and hypotenuse is AC. So I'll continue it out here on the same slide. So now I have sine 60 equal to AB is 60 and hypotenuse is what we need to find is AC. Now sine 60 is root 3 by 2. So root 3 by 2 is 60 over AC, and you will get your AC as 120 by root 3. And if you rationalize this, you'll get your AC as 40 root 3 meter. So the length of the string is 40 under root 3. Let me go over again. So this angle was given 60. This was perpendicular. We have to find hypotenuse. Perpendicular, hypotenuse means sine. So we start with sine 60. Sine 60 is perpendicular over hypotenuse, which is AB over AC. Sine 60 we know is root 3 by 2. And AB is 60 and AC is, we don't know AC. So cross multiply, AC is 60 into 2 over root 3. So AC is the length of the string, 120 over root 3. So AC is 120 over root 3 into root 3 into root 3, and this becomes AC is 40 root 3 meters. So this string that we needed to find, the height of this string is equal to 40 root 3. For the next sum, here as we read the sum we will draw the diagram. So a 1.5 meter tall boy. So we'll draw the boy here. This is the boy represented by PQ, and he is 1.5 meter tall. 1.5 meter tall. Is standing at some distance from a 30-meter building. So he's standing at some distance from a building. So this is the building, say, okay. We'll put the building as AB, and this building is now 30 meter. So we've drawn this. The angle of elevation from his eyes to the top of the building. Now let's draw angle of elevation from his eye. Now where is the eye of this boy? It will be at P, right, at the top of his body. Now the angle of elevation to the top means from here he's looking at the top of the building, so he's looking up here like this. This is his angle, this is his line of sight. This is the line of sight. Now to mark the angle of elevation, what is angle of elevation? Angle between line of sight and horizontal. So we need to draw horizontal. Where is the horizontal? This is the horizontal. We'll mark this as C here. This is our angle of elevation, and they said the angle of elevation increases from 30 to 60 as he walks towards the building. So now it is 30. Now this boy is walking towards the building. He is moving towards the building like this. Now he is in this position. Say this is position Q. We'll put this as R, so we put this as Q. Now from here again he's looking at the top of the building. Now the angle has changed. Which is the angle? Line of sight. Here is his line of sight. And the horizontal remains the same. And now the angle between the horizontal and the line of sight, this angle is become 60. What we need to find the distance he has walked. Which is the distance he has walked? He was first in this position, and now he has come to this position. So the distance he has walked is this. We got to find this distance. We'll mark this point as S. So this is the figure. So we draw the figure again a little neatly. This was the boy here. Here CPR was the boy. The angle changed from 30 to 60 as he walked towards the building. So his first position was at R, then he changed his position here at S. Then we have the building here. This is the building, 30 meters. This is the building. And we need to find the distance he has traveled. This is the distance he has moved towards the building. This RS we need to find. This was his line of sight. When he was at P, he looked at the building. This was the line of sight. Then he came at Q and again looked at the building. This was the line of sight. So let's go ahead and use Trigo and find RS, the distance traveled by him. So we start with the sum. We say PR equal to BC, and I think you'll know why. So this is because it's a rectangle, so 1.5 meters. So we start with that. So we have PR equal to 1.5 meter, and BC is also 1.5 meter. Now the entire building was given to us as 30. This entire was given as 30, which means this entire building was AB. AB equal to 30 meter. Now if you look up in the figure, you'll see AB is equal to this BC, this green one here, equal to this BC plus AC. So let's write that. AB equal to BC plus AC. Now BC we know is 30, AB is 30, BC we know was 1.5, we need to find AC. So our AC will be 30 minus 1.5, and that would be 28.5. So we'll mark this. So our AC is now here 28.5. It's 30 minus 1.5. Next we are going to work on two triangles. One is a 60 triangle, which is this one. We are going to use Trigo here, and then we'll use a 30. So we'll start with the 60. In the 60 triangle, this was given to us 28.5. So just focus on triangle AQC. AC, which is a perpendicular, is equal to 28.5, and QC is the base. We don't know, we will put it as X. The angle is 60, so we'll write, since it's perpendicular and base, we start with 1060. 1060 is perpendicular over base, which is AC over QC. So 1060 equal to AC over QC. Then we go further. 1060 we know is root 3. AC is 28.5. QC we do not know. So our QC will be 28.5 over under root 3. So we just keep it there, that we know now QC is 28.5 over under root 3. Next we'll take the triangle with 30. Now which is a triangle with 30? It is this. Here is a triangle with 30. Now for this triangle we know this is 28.5, which is the base, or which is, I mean, the perpendicular, not the base. Perpendicular. And here of course is the base. So we'll take up triangle now APC. Here we have angle is 30, so angle P equal to 30. AC is perpendicular, which is 28.5, and PC is base, which we don't know, so maybe it is Y. Now we have perpendicular and base, so we use 1060. 1030 we are using, not 60, because 30 is given here. Is perpendicular over base, AC over PC. So 1 by root 3 equal to AC 28.5, and this is PC. So PC equal to 28.5 into root 3. So we found PC. Now remember, our aim was to find PQ, to find this distance. Have you seen the distance he has walked? And that PQ is equal to, look up in the figure, you will see PQ equal to PC minus QC. So you have this entire PC, and from there when you subtract QC, you will get PQ. Now PC we just found is 28.5 root 3, and QC we found earlier as 28.5 over under root 3. So we'll take 28.5 common out. This will be root 3 minus 1 over root 3. So we go ahead, 28.5 LCM root 3, 3 minus 1. So here we'll have 28.5 into 2 over root 3. I'll just do it up here. So 28 into 2 is 57 over root 3, which is now rationalized, 57 root 3 and root 3 into root 3. So this becomes 19 root 3 meter. So the distance he has walked is now 19 root 3. The boy has walked a distance of 19 root 3. If you remember this picture, we said here this is the distance he was walking, and that distance we found as 19 root 3. From a point on the ground, let me draw one at a time. So we have the ground here. You need to draw the diagram as you're reading it. From a point on the ground, so here is the point, say P, on the ground. The angle of elevation of the bottom and top of a transmission tower fixed on the top of a building. So we have two things here. First we have a building, and on this building is fixed a transmission tower. So till here is a building, this is the end of the building, and over that is a transmission tower. So let me write now, this is building, and here is transmission tower. We'll mark the points as A here and C. This is top of the tower. Now the angle of elevation of the bottom, is 45 degrees. So let's draw angle of elevation of the bottom. This from point P, I'm looking at the bottom of the, so this is the bottom here. A is the bottom of the tower, and this is the top of the tower. So when he's looking at the bottom of the tower, he's making an angle of 45. So this is angle 45. Angle of elevation. This is his line of sight. He's looking at the bottom of the tower. Then he looks at the top of the tower. So this is the top of the tower. He's looking at the top. And when he's looking at the top of the tower, he's now making an angle of 60. So this angle here is 60. We need to find the height of the tower. So here is point B, the height of the tower. So this AB is our question. This is what we need to, height of the tower. AB is the height of the building. Height of the tower means we need to find the tower AC. AC is the height of the tower. This is our question. We need to find AC. So hope you understood the two angles of elevation. One angle of elevation is here to the top of the tower. This is one angle. And the other angle of elevation is from here to here only. So this is, let me draw it another color. This is one angle when he's looking at the top of the building, and here is when he's looking at the bottom of the tower. One angle, this is 45. So here is a diagram again. Let me mark, see here, this was the building, and then he was looking at the top of the building, and when he was looking at the top of the building, he made an angle of 45. Then he looked at the at the bottom of the tower, angle 45. Then top of the tower, he made an angle of 60. This was the tower, and the building was given as 20 meters. We need to find this H. Now to solve such sums, what you do first is find out the two angles you need to work with. Now the two angles are 45 and 60. If you look up at 45, 45 is a part of this triangle. Have you seen? This is, so I'm going to start with 45. And why do I start with 45? But this full 20 is given to me. So I'm going to start with this triangle. So I start with triangle APB. Now why did I start with APB? Because this full 20 was given to me, and it belonged to the triangle of 45. So the angle is angle APB. Just mark that APB is 45. You know AB is the perpendicular, which is given as 20, and you always find the base. The base, you see, this is perpendicular here. Let me write down. This is perpendicular and here is base. So the base for this triangle is PB, is the base, which we do not know. We will put it as X. So since we are dealing with perpendicular and base, you'll agree the ratio we want is 10. So we are going to start with 10 theta is perpendicular over base. Now in this case, our theta is 45. Perpendicular we saw was AB, and the base was PB. 1045 is 1, and AB was 20 over PB. So PB is also 20 meter. So I'm going to write down for PB. PB is 20 meter. Now it's time to take up the next triangle. The next triangle will involve 60. Now 60 is part of which triangle? Let me trace it out. So this is 60. It is a part of this large triangle. So we are now dealing with triangle BPC, and angle PBC equal to 60. Again we try to find which is a perpendicular and base. So in this case you see the perpendicular will be this entire side. This entire side will be a perpendicular, and this will be the base. So let's write that. So we have BC is the perpendicular. Look up in the figure and see what is BC. BC is 20 plus H. And what is a base? Base is PB. And if you recollect, we already found PB as 20 earlier. So this is our 20. Now we have perpendicular and base, so we use tan theta. Tan theta is perpendicular over base, and here our theta is 60. So tan 60 is perpendicular 20 plus H, and the base is 20. Tan 60 is root 3, 20 plus H over 20. You cross multiply, 20 root 3 equal to 20 plus H. Our aim is to find H, the height of the transmission tower. So the H is 20 root 3 minus 20. I take 20 common out. Root 3 minus 1 is equal to H. And that's the height of the tower. Height of the transmission tower. Height of tower, the transmission tower, equal to 20 root 3 minus 1 meters. Let's just go over the sum again. Now the diagram, you must learn how to draw it. Go to the description and draw the diagram. And now we always, in all these sums, we only use two triangles. Here one angle is given 45, so we will take this 45 here, this triangle. And there you use tan theta. Here tan 45. Tan 45 perpendicular over base. This is perpendicular. Here is base. So you have tan 45 20 over PB. 1 equal to 20 over PB. And you get your PB equal to 20. One part done. Now take up the next triangle. The next triangle will be the triangle with 60, which means you will need this triangle. And here with 60 you will do tan 60 here too. Tan 60. This is also perpendicular over base. For the 60, this is the perpendicular here, which we see is 20 plus H. And here is a base. And this base we already found out is 20 over 20. So root 3 equal to 20 plus H over 20. And then you'll find your H, you'll do your calculations, and you'll find your H is 20 root 3 minus 20. You take your 20 common out, you get your answer. So basically you're using two triangles, the yellow one, and you're using this green one. You're working in both these triangles and you get your answer. For the next one, again, as we read, we will draw. A statue 1.6 meter tall stands on a pedestal. So let me draw that. So I have a pedestal. This is my pedestal. And the top of that pedestal, say a statue. I'll just draw one person here like this. Okay, so this is the statue of a person on the pedestal. We'll just mark this. Here we have top of the statue. The statue is A and B. Then this is the pedestal. Let me write down. Pedestal is a stand where the statue is, and here is a statue. Now they said the statue is 1.6 meter tall. I think I better drop this and just draw one line, which is easier. So here is the statue, and the statue is 1.6 meter. 1.6 meter tall. Then of course we have the ground, and from a point on the ground, so we've got to take a point on the ground. We'll take this point here, we call it P. Now what is happening from P? The angle of elevation of the top of the statue. Now which is the top of the statue? Here is top of statue A, and let's mark the bottom of the statue. B will be the bottom of statue. Now from the angle of elevation of the top of the statue is 60. So from this point he is looking at the top of the statue. So his line of sight is here. He is looking in this way. This angle is 60. So the angle between the horizontal and the line of sight is 60. From the same point, the angle of elevation of the top of the pedestal. Now the top of the pedestal will be at this point B here, top of the pedestal, and now he's looking at the top of the pedestal. So line of sight, and the angle here, this angle is 45. I'll mark this here, 45 degrees. We have to find the height of the pedestal. Now which is the height of the pedestal? This H. This H we need to find out. So hope you understood the line of sight. This is the line of sight for top, which makes 60, and then this is the line of sight for the top of the pedestal. So this is our 60 here, this full thing is 60. However, this here is, the full thing here is 60. So we have to find H. So here's a proper diagram. P is a point of observation. Here is our statue which stands on our pedestal, and from P this man is looking at the top of the pedestal. The top of the pedestal is out here. B is the top of the pedestal, and he looks here at the top of the pedestal, and when he's looking top of the pedestal he's making an angle of 45, and when he's looking at the top of the statue, which is out here, he makes an angle of 60, and our question is to find the height of the pedestal. However, the height of the statue is given as 1.6 here. Have you seen? This is given as 1.6, this height of the statue. So here's the diagram once again. Now we got to choose two triangles from where we work. One triangle is of 45, so let's mark the one with 45. So this is the triangle we are going to work with. One triangle which is of 45. So if you see here, the triangle is PBC, and in PBC the angle is given to us BPC is 45. Let's write its perpendicular and its base. So this is its perpendicular here, and here is the base. So we'll write that out. So we have the perpendicular, which is BC. We don't know the perpendicular, we take it as h meters. The base we see is PC. We don't know the base either, so we just keep it that way. Okay. Now perpendicular and base we always use now 10. 10 theta is perpendicular over base. So in this case we have 10 or 45. We saw the perpendicular is h, the base is BC. So we have 1 equal to h over BC. And I'm going to write BC is equal to h. Now why I did that I'll explain to you later. So we have dealt with one triangle which is of 45. The other triangle is of 60. So the triangle with 60 here will be here, right? So this is a triangle APC. The angle, this is the angle that we want, that is angle APC equal to 60. We need to know its perpendicular and its base. For this, you see what is a perpendicular. This is our perpendicular, which is AC. Look up in the figure and see what is AC. It is 1.6 plus our H, right? It is BC plus AB. So it is 1.6 plus H. And the base is PC. We don't know the base either, so we just keep the base as it is. Again, we are going to use 10. Okay, and that is 10 is perpendicular over base. In this case, our angle is 60. See here, this is 60, which is perpendicular AC over base PC. 1060 is root 3. AC is 1.6 plus H, and PC, and we have here over base. Base is BC, right? PC, I mean PC is base. Yeah, this is a mistake I made here. This should be PC, right? Not BC. PC. So here is PC. So when I cross multiply, in this case I get PC equal to 1.6 plus H over root 3. Now have you noticed something? I found PC in two triangles. I found PC out here in this triangle, and I also had found PC earlier in the yellow triangle. So let me equate the values of PC. So I will write here now PC equal to PC. First I found PC as H. Here I found as H. And on the other side I found PC as 1.6 plus H over root 3. Now I just have to cross multiply and find the value of PC. So this is root 3H equal to 1.6 plus H. I take all the H terms together, root 3H minus H equal to 1.6. Now I'll take H common out. So root 3 minus 1 equal to 1.6. Here we have, so our H is 1.6 over root 3 minus 1. Now we need to rationalize this. So 1.6 over root 3 minus 1 multiplied by root 3 plus 1. Here root 3 plus 1. So H is 1.6 root 3 plus 1. A plus B, A minus B, A square minus B square. So H 1.6 root 3 plus 1, 3 minus 1. H 1.6, and this is 2. When I cancel this, I get 0.8 root 3 plus 1. So this is the height of the pedestal. We need to find height of pedestal. So height of pedestal equal to 0.8 root 3 plus 1 meter. Now for the next one, again, as we read, we will draw the diagram. The angle of elevation of the top of the building from a foot of a tower is 30. So we require a building and a tower. So we have the ground here. On one side we will draw the building. Say this is the building here. We'll mark it as AB. AB. And then we have the tower. So we'll draw one huge tower here, and we will mark this as PQ. Now we require foot and tower, a foot and of the building top. So we'll just write down now here. This is foot of the building. Remember, this is building. And here is a tower. First, we'll just focus on drawing the diagram properly. Foot of the building, and this is top of the building. Here this is foot of the tower, and this is top of the tower. So let's start now drawing it. So the angle of elevation of the top of the building from the foot of the tower. So top of the building, foot of the tower. Where is top of the building? This is top of the building. Foot of the tower here. So this is your line of sight. You are standing at the foot of the building and you're looking at the top of the tower. So here is what you are doing. This is the angle. And this angle is 30 degrees. This angle of elevation, they've given it as 30 degrees. One thing done. Now for the next, here we are now looking at the angle of elevation of the top of the tower from the foot of the building. So let me mark top of the tower. Here, top of the tower from foot of the building. This angle. Now this is the line of sight here. This is your line of sight. And this angle they're saying is 60. So here we just draw this up. So this angle was 60. So this is our figure. And they said the tower is 50 meter high, this tower. And this is our tower. So this is our 50 meter high. So this is the diagram. What is important is to mark the angle of elevations. So here's a figure. Here was your building here. Then we had the tower. This was the tower. We had the angle of elevation from the foot of the building to the top of the tower. This was given as 60. And the angle of elevation from the foot of the tower to the top of the building, which is this, was given as 30. And now we have to find the building. And the tower was given as 50 meters. So we got to now find the answers from this diagram. So here's the figure again. Now remember, we always work with two triangles. One triangle will have 60 and the other one will have 30. So this is the triangle of 60. So I'm first going to start working with this triangle. Yeah, PB, QB. Okay, this triangle, let's mark its perpendicular. Here will be the perpendicular. This will be its base. So I'm going to write triangle PQB. The angle PBQ is 60 degrees. Its perpendicular, which is PQ, will be 50 meter, and that is given to me here. This 50 meter is given, the perpendicular. And the base in this is the base BQ, which I don't know, and I'm going to find it out. So since perpendicular and base, we use 10 theta perpendicular over base. So 1060 perpendicular PQ, base BQ. 1060 root 3, 50 PQ, BQ. So we have BQ equal to 50 over root 3. I will keep it at this. So we know this is BQ is 50 over root 3. Now it's time to take the next triangle. The next triangle will have the angle 30. Now which is the one that has angle 30? This triangle. That is triangle ABQ. And the angle there is AQB equal to 30. Let's write its perpendicular, let's write its base. So here is its perpendicular, this is the base. Perpendicular AB, which we don't know. It is a question, okay? And our base here is BQ. But we have found BQ here. If you remember, we found BQ in this. So we'll write 50 over root 3. Now again we use 10 theta perpendicular over base. In this 10 is 30. Perpendicular here we see is AB, which we don't know, and that is our question, to find the building. And our base is BQ. 1030 is 1 by root 3 equal to AB, which we don't know. BQ is 50 over root 3. Cross multiply. 50 over root 3 into 1 by root 3 equal to AB. So AB equal to 50 over 3. So AB, which is the height of the building, equal to 50 by 3, and that is 16 2 by 3 meter. So that is your answer, 62 by 3 meter. Let's go over the sum again. So first we started with 60. We started with this triangle. Why did we start with this triangle? Because this full side, this was given to us, a perpendicular was given to us. With the help of 10, the perpendicular was given to us, we found the base. So we did here like 10, 60, a perpendicular 50 over the base. Base was BQ. We cross multiplied and we found our BQ is 50 over root 3. So this was 50 over root 3. Then we took the other triangle with 30. This was the other triangle with 30. Now in this triangle of 30 also, this was perpendicular here and the base was the same. So we did 10, 30. Perpendicular, which we don't know, and the base in this case was 50 over root 3. And we solved this. 1 over root 3, which is 10, 30, is perpendicular over 50 over root 3. And we got here 50 over 3 is perpendicular, which is the height we required, height of the building.